Welcome to the second video lecture for Chapter 2. In this section, we will cover projectile motion for both horizontal and different angled launches. A couple of vocabulary words that you'll see often in problems for this section, 3.3 on projectile motion. First of them would be hang time, which we've already talked about as the total time of projectiles in the air. Often, a useful thing is knowing half the hang time in the time that it takes the projectile to get to the top and then to change direction and fall back down. Another common thing asked to solve for is the range. This is the total displacement a projectile travels in the horizontal direction. And last, you want to know the maximum height. This is useful or easier to find once you know sometimes half the hang time, because you can find that velocity at the top there is 0 meters per second. Notice that the range is in the horizontal or X direction, and the maximum height will be in the vertical or Y direction. In projectile motion, acceleration due to gravity is always going to be in the vertical direction. While this seems pretty straightforward, it is often forgotten. This means that the velocity in the X direction does not change. This makes all of our equations a little bit simpler and easier to use. Acceleration in the vertical or Y direction is always going to be a negative 9.8 meters per second squared. Please make sure it's negative. This is something very important as we get into harder problems such as upward launches. At this point, we're only going to be concerned with horizontal launches. As mentioned, right now all we're going to look at is horizontal launches. A horizontal launch is when something is launched off a table with only an X velocity. In this case, the Y direction, or vertical component, is going to be the same as if something is dropped from rest. You should already be comfortable in solving this. You can look at solving that part as just a one-dimensional motion problem. That's just for the Y direction only. Notice here with the lines drawn for the vectors that the total speed or velocity, the larger diagonal arrow directed kind of at an angle downward, is made up from the two components both in the X and the Y direction. Let's try a sample problem for a horizontal launch. A ball rolls out a 25-meter high window with a velocity of 6 meters per second. This means that the velocity is in the X direction. We want to know how long does it take to hit the ground, how far from the building does it take to land, that's going to be the range, and what speed does it hit the ground with. To do this, we're going to need to break apart each of our equations into both the X and Y direction. Whenever looking at problems in two dimensions, the limiting factor becomes time. We need to separate our variables into both their X and Y direction and look at which ones give us the most information to be able to solve for time. For right here, we have our acceleration in both the X and Y direction. You should remember what these are from earlier on in the lecture. We also have our initial velocities in both the X and Y direction. Because this is a horizontal launch, the initial velocity in the X direction is going to be 6 meters per second, and in the Y direction, we have 0 initial velocity. Now, in setting up our position, initial X direction, we're going to set that as 0. This is because we're going to be looking for the range, or the distance, in this case, from the building. For the Y direction, we can easily set up our direction, our position as both 0 or 25. It will not make a difference as we move forward. But for this case, let's set it up as our height as 25 meters and go from there. Taking a look at the Y direction, we have several known quantities. First, we know our acceleration is always going to be negative 9.8 meters per second squared. In this case, we also know our change in position. That's going to be the 25 meters that the object falls. We also know that because this is a horizontal launch, we have an initial velocity in the y direction of 0. This makes the problem become simply something as if it were dropped in order to solve for the time it takes to hit the ground. This is because you can look at each component, the y and x, as separate. So take a moment now and solve for the time based on this information and the equations that you are familiar using. Now that you have solved for the time, it's pretty much just a plug and chug problem. Keep in mind that the time in any type of launch problem of 2 dimensions is going to be the same. You can't have the ball or object traveling for a longer period of time in the y direction than in the x direction. So take a moment right now and use any equations that you know and have written in your notebook to solve for the range and both the final x velocity and the final y velocity. Using then those two velocities, combine them together using the Pythagorean theorem and solve for the speed that the object hits the ground. I hope that this lecture is really starting to help you build your understanding of projectile motion. And if you have any questions, please make sure to come to class and ask them. Thank you very much, and have a good night. Ah, dang it, my pen rolled off the table. Shucks.